All right, here we go. We're going to spend 15 minutes, and then you're moving on to the next review. The questions we don't get covered today, I will cover them online and post the video, Zach. All right, raise your hand, please. You have a question, Mallory. 4. All right, so on 4, limit, x approaches 2. What does that plus mean? Right side of f of x. I don't want blurting out. I'm going to ask questions. You're going to raise your hand. Zach?
If you plug into 4x plus 3.
We're going to plug into 4x plus 3. Why?
Because it says x is greater than 2, which is the right side.
All right, so the right side of 2 would be values greater than 2. So that means we need to plug 2 into 4x plus 3. So I'm going to get 4 times 2 plus 3. So that means our limit is 11.
So that's it?
That's it.
Okay, so I got it just like that now.
All right, what else?
Isn't a horizontal asymptote 0 over number?
Mm-hmm.
Okay.
Well, no. We need to visit that.
Okay.
Which one are you looking at?
I'm looking at 20.
You're looking at 20. 20 is the one I told you to omit.
Okay. Well, about 19 minutes.
I'll just give that.
Do 19.
All right, so on 19 we have this function. It says if the line y equals b is a horizontal asymptote to the graph of f, then b equals. So all this problem is really asking for is what? Find the horizontal asymptote. So raise your hand if you can remember how to find the horizontal asymptote. Roshan?
Look at the powers of the top and bottom.
Look at the powers of the top and bottom. So what's the powers of the top?
1.
No.
Oh.
Remember, you gotta, if I were to multiply this out, that right there is going to produce my largest power, which gives me negative 12x squared. And on the bottom, my largest power would be 4x squared. Now, there's 3 different things that can happen right here. Raise your hand if you can tell me the 3 scenarios of what I'm going to see right here. John Ryan?
So the top exponent can be larger than the bottom exponent can be larger than the top, and the exponents can be the same.
All right, so if the top's bigger, what's going on? Does not exist, and then you need to decide if it's going to positive or negative infinity. All right, if they're the same, such as in this situation, John Ryan, what do we do?
Simplify the coefficients.
Simplify the coefficients. So in this case, my horizontal asymptote is going to be negative 3. And if the bottom's bigger, John Ryan?
0.
0. Very good. So top's bigger, D and E headed to either infinity or negative infinity. Bottom's bigger, 0. If they're the same, then I take the coefficients and get that. Technically, does anybody know technically what we're doing here whenever we find the horizontal asymptote? No. What is it we're interested in if we're finding horizontal asymptotes? What? My y. I need a little bit more.
The y value where it like never touches, it gets exceeded.
I'm wanting my y value at a specific location is what I'm looking for. So if I'm looking for horizontal asymptotes, I'm interested in the y value, but where am I interested in the y value at? Maddie? Nope. Infinity or negative infinity. Okay? And since we can't plug in infinity or negative infinity, what is it that we need to take? Since I can't plug in infinity or negative infinity. Nope. What did we do in this packet? A bunch of this packet. Limits. So technically, when you want a horizontal asymptote, technically what you're doing is taking the limit as x approaches infinity. Okay, so technically what I'm doing here is taking the limit of this thing. All right.
So actually you could rewrite the problem like that.
This right here also equals that. This is just, yes, very good, Abby. Abby said to work this out, we do L'Hopital. So what you want to do is you want to multiply all this out and then take L'Hopitals, and eventually you're going to get to just numbers, and those numbers would reduce to -3.
So basically, hold on, that's to make it as linear as x approaches infinity.
Yes. If it asks for what is the horizontal asymptote, this is what you're doing.
So what
If you can't figure it out, this way, this is what you're doing, and then you evaluate the limit.
when would it be a negative infinity?
When would it be a negative infinity? All right, so let's change this and make it. Let's change it and make it this. Okay, so let's say I'm headed towards infinity. Plug in infinity in the top. Would the top be positive or negative? Negative. Bottom be positive or negative? Positive. So a negative over a positive would tell me negative infinity. If I plug in a negative infinity, top is. Top's still negative. This top's always going to be negative. And the bottom is negative. So a negative and a negative gives me positive infinity. Okay. All right. Mallory? 12. All right, same situation here. It says vertical. Oh, no, it's different. It's a vertical asymptote. All right, so vertical line x equals 4 is an asymptote of the graph of the function f. So 1, 2, 3, 4. I've got a vertical asymptote. Which of the following statements must be false? Okay, and if you notice, the top 3 deal with x approaching 4. What do we always say? Your only 2 options are anytime you're approaching an asymptote. It's got to go to infinity or negative infinity. So that automatically tells me my answer is A. A is not possible. A is not possible because if I'm approaching an asymptote, my only 2 options are infinity or negative infinity. It cannot equal 0. Okay, the other 2, D and E, what is that saying? Yeah, we're talking about a horizontal asymptote. And there's nothing in here that tells me these horizontal asymptotes could or could not happen. Okay, so the only one that can't happen is definitely A. Everybody with me on that? All right, raise your hand, please. Mallory? 16. All right, is there a C in the closed interval from 0 to 2 such that f of c equals 0 for the function f of x equals x to the 5th minus 2x cubed minus 2? Raise your hand if you know what's going on this problem. What do you got, Carter?
Trying to find c equals it touches the x-axis. Does it seem x-axis?
Kind of. In this case, it touches the x-axis because it said f of c is 0. But it could say f of c equals some other number. Anybody know what we're dealing with on this problem? Ryan? We're using the IVT. What does IVT stand for? Intermediate value theorem. So somebody else besides Ryan, tell me what the process is on intermediate value theorem. What do you got, Ivan? There you go. And what's the prerequisite for the IVT? Very good. My function has to be continuous. Okay, so f of x equals x to the 5th minus 2x cubed minus 2. My interval is 0 to 2. Okay? So when I look at my function and I'm concerned about continuity, what are the things that I should be looking out for? Hang on, raise your hand, please. I want somebody to have you. Fraction. Trig. Piecewise. I think there's one more. Radical. Okay? But in this case, do I have any of those? No, so what does that tell me about this function? It's continuous. So I can say f is continuous on 0 to 2. You have to establish that. Okay, and then what did Ivan say the next thing is to do? What? Plug in my endpoints. So f of 0, f of 2. So 0, pretty easy. That's going to be negative 2. If I plug in 2, that's going to be 32 minus 16 minus 2. So I think that's 14. Okay. And then what do I need to show next? I need one more thing before my statement.
Is it where you would set up as an equation to be like f of 2 minus like f0 over like?
Nope.
F of 0 is less than 0, which is less than
All right. You have to establish that the y value you're interested in, this y value right here, you have to establish that's in between the two y values you just found. Okay, and then once you do that, then it's just your statement. Anybody remember what the statement is?
Such that.
All right, therefore by the IVT, there exists a C on 0 to 2 such that f of c equals 0. Very good.
So what would make it not exist?
What'd you say?
What would make it not exist?
Would it make it not exist if the function is not continuous, or if the y value I'm looking for is not in between the two y values I found? So if you're continuous and the y value I want is in between the two y values I found, we're good to go. If either one of those is a no-go, then you can't guarantee it.
So say like that equation in the square root, how would you determine if it was continuous?
I would figure out, set it equal to 0, figure out what's going to make it negative, what's going to make it positive. And if this shows up in what makes it negative, then I can't do it. But if this is on the positive part, then I'm fine.
Can we do an example of one of those?
Alright, so let's say my function is the square root of x plus 2. My interval is negative 1 to 5. I want to know, is there a y value that equals 0? Okay, and again, even though both of these problems have used 0 right here, you can put any number in there. Alright, so what are my concerns with this radical?
Continuous.
Whether or not it's continuous. So I need to know what's going to make it negative. So you set the inside equal to 0, which gives me negative 2. So one side or the other of negative 2 is going to make me negative inside. Which side of negative 2 is going to make me negative inside, the left or the right? The left side. So that means I can only use the right side of negative 2. Do these numbers fit on the right side of negative 2? Yes. So that means I can say f of x is continuous on negative 1 to 5. Okay? If it's not, then you say f is not continuous and IVT cannot be applied. Alright, next thing. Next step, plug in. So I need f of negative 1. I need f of 5. So I plug in negative 1, gives me 1. Plug in 5, gives me square root of 7. Alright, what do I consider next?
F of negative 1.
If 0 is in between these two values. Is 0 in between those two values? No. So then I say MVT or IVT cannot guarantee it. And I'm done. If it is in between, then I write my statement. All right. Set up my inequality and then write my statement. All right. What time does class start? 5 after? Okay, so we do 10. All right, I'll do one more. That 15. All right, determine the value of k so that f of x is continuous on the entire real line. Raise your hand. I want somebody new. What 3 things must happen in order to prove something is continuous at a point? Raise your hand, please. Somebody new. Elite.
A value has to exist.
Function value has to exist.
Limit has to exist.
Limit must exist.
And they both have to equal each
And they have to
other.
equal each other. Very good, Elite. Okay. So, since I'm dealing with a piecewise, which one of those 3 do I want to get started with? The limit. I'm interested in the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. So which piece do I plug into for the limit from the left, top or bottom?
Bottom. Your top.
Top. So I plug in 3, I'm going to get 11. Which piece for the right? Bottom. So I plug in 3 in the bottom and I get 18 plus k. And in order for this to be continuous, what must be true about 11 and 18 plus k? They have to equal each other. So I do 11 equals 18 plus k. Subtract. We find out that k has to be negative 7. So if I stick negative 7 in here, I have created a function that's continuous at the x value of 3. All right, we're looking at test 1, semester review answers. Number 1, the graph of f is shown in the figure. Which of the following expressions equals 2? F of 3 would be if I go to 3 and then I'm looking for the closed dot. So f of 3 would be 4. The limit as x approaches 3 from the left. So here's 3. So if I have an imaginary vertical line there, where is that vertical line being touched on the left? It's being touched on the left by this piece, and then the y value that matches up there is 2. So this right here equals 2. So that's going to be our answer, but we'll keep going. Limit as x approaches 3 from the right. So my vertical line at 3 coming in from the right side. This time that would be 6. So the answer to this one is 6. And then the limit as x approaches 3. So that means the left and the right have to be the same. But we just said that the left was 2, the right was 6. So therefore D would be D and E. But the correct answer to number 1 is B. Number 2, the table above gives selected values for a continuous function f. Based on the data in the table, which of the following is the best approximation for the limit as x approaches 3 of f of x? So 3 is going to be right here in the middle. So I want to know, what am I doing as I come in from the left? What am I doing as I come in from the right? Remember 2 things. These values right here, all of these values have to be very, very close. If they're not very, very close, then you're not going to have a limit. In this case, they're all very, very close. And then in the middle, between these 2 values is 5, so that means 5 is going to be our limit. On number 3, limit as x approaches 0 of sine of 5x over x. On this one, you can do this one of 2 ways. You can use a special trig limit, or you can use L'Hopital's. I would recommend L'Hopital's. It's a little bit easier than having to remember the special trig limit. So I plug in 0, I get 0 over 0. So we take the derivative. Derivative of sine is cosine. Derivative of the inside is 5. So I have 5 cosine 5x. Derivative of x is 1. We plug in again. So I plug in 0. So cosine of 0 is 1. 1 times 5 right here. And on the bottom, I just had 1. So I end up with 5. This equal sign right here shouldn't be here. It should be the limit as x approaches 0 of this thing. Number 4, we went over number 4 in class. Number 5, limit as x approaches 0 of the square root of x plus 4 minus 2 over x. You could do L'Hopital's rule on this one, but it's pretty nasty since you have a radical. So the easiest way to do this one is multiply by the conjugate, which we did here. Leaves me with x plus 4 minus 4 on the top. So that reduces to x. The x's cancel. Leaves me with 1 over this. Remember, once you cancel something out, that's when you want to plug in again. So I plug 0 in. Square root of 4 gives me 2. 2 plus 2 gives me 1/4 right here. So 1/4 is my answer. On this one, remember on this problem that my answer is always going to be 1 or -1. So I just have to figure out which one it is. I plug in something on the left of 3, so let's plug in 2. 2 minus 3 is going to give me a -1. On the bottom, 2 minus 3 is going to give me a -1, but it turns positive. So I have a -1 on top of a +1, which means my limit is -1. All right, again, number 7, plug in 0. So I plug in 0. I get 1 minus 1 on the top, and I get 0 on the bottom. So let's do L'Hopital's again. Derivative of 1 is 0. Derivative of cosine is negative sign. So I got 2 negatives there, which make it a positive sign. Derivative of x squared is 2x. Plug in 0. I get a 0 on the top. I get a 0 on the bottom. So we need to find the derivative again. Derivative of sine is cosine. Derivative of 2x is 2. I plug in. Cosine of 0 is 1. And then I have 2 on the bottom. So my limit is 1/2. Number 8, plug in 0. I get 0 on the top. I get 0 on the bottom. Again, if I wanted to, I could use L'Hopital's. But since I'm x to the 5th and I'm x to the 5th on the top, it would take a lot of derivatives to get to my answer. So in this case, you're better off factoring and canceling. So we factor out an x to begin with, gives me that, and it leaves me with this. I plug in my 0 again, so that goes away, that goes away. I'm left with 12 on the top. That goes away, I'm left with 4 on the bottom. That reduces, it gives me 3. Number 9, again, regardless of the fact that it wants 3 from the right, we still want to start by plugging in. So I plug in 3, I get 6 minus 5, which is the square root of 1, and the square root of 1 is 1. Remember, the first thing you always need to do when you're finding the limit is plug in. And as long as you don't have any issues, that's going to be your answer. So this one right here, make sure you plug in. Number 10, I plug in. 2 minus 2 gives me 0, so I have a number over 0, which means I'm dealing with an asymptote. As we talked about today, when you're approaching an asymptote, you're either going to infinity or you're going to negative infinity. So we're going to plug in 2 from the left, so we want something just to the left of 2 and determine whether or not it's going to be positive or negative. So just to the left of 2 is going to make my denominator negative. So 1 over a negative is going to give me negative infinity. So this one technically does not exist, but we can go ahead and say it heads towards negative infinity. 11, plug in -3, we get 0 over 0. Again, I could do L'Hopital's, but that would be pretty nasty to find derivatives in there. So I'm gonna go ahead and get a common denominator on the bottom, which gives me 3 plus x over 3x. So now I take x plus 3 divided by what's on the bottom, change the division to multiplication, flip it over here, the 3x, or the x plus 3, and the 3 plus x cancels, leaves me with 3x. I plug in the -3, we end up with -9, so my limit there is -9. We talked about number 12 in class today. 13, the figure shows the graph of function f. Which of the following statements are true? So first one, limit as x approaches 2 from the left is equal to f of 2. So we're approaching 2 from the left. So 2 from the left is going to be this piece right here, and we're going to -1. F of 2 is going to be where my closed dot is, which is here. So both of those things are in the same place, so that means 1 is good. We like 1. So we can automatically eliminate A, B, and D. My only choices are E or C. Next one, limit as x approaches 6 from the left equals the x approaches 6 from the right. So 6 is right here. From the left, I'm going to -1. From the right, I'm going to -1. Those two are both going to the same place. So that means 2 is good. So we're still alive on E and C. Then it says the limit as x approaches 6 is f of 6, or equal to f of 6. So my limit is going to be here. F of 6 is going to be here. They're not the same, so therefore 3 is no good. So that means C is going to be my answer. All right, 13b, we're still using the graph from 13a. What are the all values for which values of x for which f has a removable discontinuity? Removable discontinuity, if you're looking at it graphically, means that you could plug a hole. Okay, you're just looking for a hole. I cannot plug a hole here. Okay, but this hole right here, I can move this y value up to here and plug that. So since I can plug it, that means I have a removable discontinuity. So that's why my answer is x equals 6. This one, I cannot plug it. I would have to move both pieces, one or both pieces, to get it to match. Here, I can plug it, and then we're good to go. So if you can plug it, that means you're dealing with a removable discontinuity. X values for which we're discontinuous. Remember, we're interested in what makes the denominator 0. So 2 is going to make me 0, and -1 is going to make me 0. Remember, removable is what makes the numerator and denominator 0. Non-removable means I'm going to have a number in the numerator and a 0 in the bottom. So if I plug 2 in, notice if I plug 2 in right there, makes the top 0, plug 2 in right there, the bottom 0. So since both the top and the bottom are 0, that means it's removable. Plug in -1. -1 makes my bottom 0 here. -1 does not make it 0 here. It does not make it 0 here, which means I have a number in the numerator. Therefore, I am non-removable. So that means there's going to be an asymptote at -1. We looked at 15 in class today. We looked at 16 in class today as well. 17, let f be the function defined by f of x equals 2x plus 3 over x plus 1. Which of the following statements are true? The graph of f has a horizontal asymptote at y equals 2 because the limit as x approaches infinity of f of x equals 2. So look at this horizontal asymptote. Notice exponent is the same top and bottom. I take the coefficients, so 2 over 1 does give me 2. So my horizontal asymptote is 2, and we talked about today that if you're wanting a horizontal asymptote, that means you're approaching infinity or negative infinity. So I like number 1. Number 2, same thing. The only difference between 1 and 2 is we're going to infinity or negative infinity. Again, it's not going to make a difference if my exponents of the top and bottom are the same. So I like 1 and 2. Vertical asymptote at x equals -1. -1 does make the bottom 0. It does not make the top 0, so it is a vertical asymptote. And it says because x approaches -1 from the right and we're headed towards infinity. Remember, if it's a vertical asymptote, then that means you can only go to infinity or negative infinity. So in this case, -1 from the right says it's going to infinity, so that verifies it is a vertical asymptote. So we like all 3 of these choices. All right, so I have f of x. Which of the following statements at x equals -2 and x equals -3 is true? It's talking about discontinuities again, so we're in that same situation. I went ahead and factored the top. It makes it easier to plug in if it's factored. So I took an x out. That left me with x squared minus 9, which factors into x minus 3, x plus 3. It's just easier to see what makes the top 0, what doesn't make the top 0. So I can notice real quick that -2 is not going to make my numerator 0. So that means -2 cannot be a removable discontinuity. On the bottom, we want to see if both of these make the bottom 0. So if I plug in -2, I think I plugged in -2 right here. So -2 cubed is -8. -2 squared is 4. -2 times -8 is 16 and gives me that. So that does gives me 0, and I went ahead and plugged it in the top as well. Gave me a number over 0, which verifies we have an asymptote. On 3, plugged in 3 here. We got 0 on the top, and we got 0 on the bottom. Since I have 0 over 0, that means we have a removable discontinuity. So I need a vertical asymptote at -2, which is what we got from the number over 0, and a removable discontinuity at 3 since we got 0 over 0. You're only going to get jump discontinuities if you're dealing with a piecewise or if you're dealing with one of those absolute value problems where either the top or the bottom is in absolute value. So if you don't have an absolute value or a piecewise, you're not going to have a jump discontinuity. So we could have eliminated those two pretty quick. The next one, we did 19 in class, and I told you to skip 20. 21, graph of the function f is shown in the xy plane. F has a discontinuity due to a vertical asymptote at x equals 6. So I have a vertical asymptote right here at x equals 6. Then we have g. So we have some stuff from g down here in a table. It says, using the graph of f and the table of g, estimate the limit as x approaches 0 of f of x minus g of x. So I want the limit as x approaches 0 of f of x. So 0 is right here. Both sides are going to 2. So that means that value is 2. 0 is right here. These values are close. These values are close. 2 is in the middle. So that gives me 2 minus 2, which means that answer is 0. Then we want, for each value, 1, 2, 4, and 6, we want the limit of f of x for each one of those, 1, 2, 4, and 6. So 1 is right here. Notice from the left, we're here. From the right, we're here. So that one's D and E. Next one is 2. 2 is right here. From the left, we're going there. From the left, we're going there. We're both going to 1, so my limit is 1. Remember, it does not matter on limits whether or not there's an open or closed circle or whether or not there's a circle or not. It just matters that you're going to the same spot. 4, again, right here. No open circle, no closed circle, but I still have a limit, and that limit is -1. And then the last one, limit as x approaches 6. Right here, we've got a vertical asymptote. So that means we're either infinity, we're headed to infinity, or negative infinity. In this case, both sides are going up. So that means we're headed to infinity. So D and E headed to infinity. If one side was going up and the other side was going down, all we could say is D and E, unless they want it from the right or from the left. So if I want both sides and they're not going to the same place, then all I could say is D and E. But in this case, both of them are going up, so we can say D and E headed to infinity. Is f continuous at x equals -3? Remember, we talked about today the 3 things that have to happen in order to be continuous. I have to have a function value, I have to have a limit, and then those 2 things have to equal each other. So -3. Do I have a function value at -3? Yes, my function value is up here, and it is 2. So yes, function value is there. Do I have a limit? Yes, I have a limit. My limit is down here. It's -1. So there's my limit. There's my function value, but as you see, these 2 values are not the same. So the limit does not equal the function value. Therefore, we are not continuous. All right, we got f, g, and h right here, and we want to find these limits. So limit as x approaches 5 of 10 times f of x plus g of x. So f of x is right here. I'm going to plug 5 in. 5 minus 3 is 2. 2 squared is 4. 4 plus 5 is 9, and then I multiply by that 10, so that's where I got 90 from. And then plus g of x. So I plug in 5 and g, so 5 minus 3 is 2, 2 cubed is 8, 8 plus 3 is 13. Put those 2 together, I get 103. All right, 10 times f of x, we just learned that was 90. And then, we're going to infinity. Let me back up. So as I go to infinity here, or I have 10 times this thing, and I'm noticing I should have put parentheses around it. So right here, I should have put parentheses right here, around there. It may not matter though. All right, so let's try that again. So since I'm going to infinity, I want to look at the exponents, or I want to do L'Hopital's rule. Or sorry, I want to look at the exponents. L'Hopital's rule works too, because if I plug in infinity, I get infinity on the top and infinity on the bottom. Infinity over infinity, I'm allowed to use L'Hopital's. But in this case, it's easier to use the exponent deal. Notice the top exponent is 2 and the bottom exponent is 3. So the bottom exponent is bigger than the top, which means we're 0. All right. And remember, the 3 situations are, they're the same. If they're the same, then we want the coefficients. If the bottom's bigger, it's 0. If the top is bigger, it's D and E, and then you got to say where it's headed. Limit as x approaches 5 of h of x. So h of x is right here. So another one of these. So that thing either has to be 1 or -1. We are approaching 5, so that means we have to have the same thing from both sides. So if I'm approaching 5 from the right, the top's going to be positive, bottom's going to be positive. So from the right, I would have a 1 here. 2 plus 1 gives me 3. And from the left, I would have a negative on the top, a positive on the bottom. So it'd be 2 plus a -1, which gives me 1. Those two things don't match. So as you notice, from the left, we were 1. From the right, we were 3. Those two things don't match. So therefore, the limit doesn't exist. And last one, limit as x approaches 3 of h of x. So I plug in 3. So 3 minus 5 gives me a -2 on the top. 3 minus 5, absolute value, gives me a -2 over a +2, which means this is -1. 2 plus a -1, 2 minus 1 gives me 1. So that's my limit. All right, so there is test 1, semester review answers.